Okay, so we're looking at revision of last year again. So we're looking at equations of tangents and normals. So hopefully you've picked up again that the derivative helps us find the gradient of the tangent at any point. So I've got a diagram there where there's a tangent to a certain point and then the normal is at right angles. And so you have to remember that the two gradients, the gradient of the normal and the gradient of the tangent, always multiply to give -1. So that's really important. So copy that down, and when you're ready, come back to the next slide. Okay, so this is, sorry it's a little bit long, I've pre-recorded this, so obviously. So before we go to tangents and normals, let's just a quick review of just substituting x values to find gradients. So there's an example of a nice straightforward parabola. Fx equals x squared minus 2x plus 7. Find the gradient of the tangent at x equals 5. Find the gradient of the normal at x equals 3. And the last one is you don't know the point, but you know the gradient, so you have to backfill, so to speak. So in the first one, the first step is you've got to find the gradient, so you've got to find the derivative, and once you've done that, then substitute the value of x. So fx was at the top, f dash x, just using the simple rule, is 2x minus 2, so f dash 5 is a straight substitution, and you get 8, so the gradient of the tangent is 8. That's straightforward. You don't know what the equation is, but you know that the gradient is 8. For the second part, we're looking at the normal, so we just put the value in, we get a value of 4, and once we know that the tangent is 4, then the normal is -1 on 4, and I've put the question why, but if you look at the previous slide back here, that's really important. So what you do is once you've got the tangent, once you've got the gradient of the tangent, then you just flip that gradient. So 4 becomes 1 over 4, and make sure you change the sign. Okay, and the last one, you know the gradient is 1, so you put 1 out the front, and then you just solve for x, but because the question said find the point, you also need to find the y value. So there's the x value, and then you sub into the original equation, and you find the y value, so that's the point. Okay, copy that down, that's a good example. And when you're ready, come to the next slide. Okay, so back to tangents and normals. So we've got my first diagram roughly drawn, and so as I've got, so both tangents and normals are straight lines, and so all straight lines are of the form y equals mx plus b, where m is the gradient and b is the y-intercept. And we're using calculus, we're using the derivatives to help us find the gradient of the tangent, and then this value here will come from a substitution. Once we know the value of x, we can find y, and that's what our next example will be. So copy that down, and then when you're ready, come to the next slide. Okay, so we're just going to do two examples, an example for a tangent and an example for a normal. So you can see the question, so the steps are find the derivative, substitute x to find the gradient of the tangent, and then the last part is just find the value of b by substituting x back into the original formula to find y, and then just do a really simple equation. So the derivative is straightforward, the gradient of the tangent is straightforward, and then so this is the general form, y equals mx plus b, so we've found that by derivative. That still we don't know yet, but when x is 1, we can substitute back into the original equation and find what the y value is, and then just y equals mx plus b, and find the value of b. Now obviously there is another way of doing it, and that's y minus y1 equals m bracket x minus x1. So we'll do it quickly. So we've got y, and the y value is -1, so that'll turn into +1. The m value is -3 bracket x minus 1, multiply out, put the plus sign there, and then take the +1 across, which will become +3 becomes +2, and lo and behold, it's the same. What a surprise. Okay, so it doesn't matter whether you use this form of a straight line or y equals mx plus b, so it just depends on which one you want to use. Okay, copy that down, and when you're ready, come across to the next slide. And the last one is just find the equation of normal. It's exactly the same. All I've done here is I've just given you the point, so that means that saves you a step. You don't have to find the y value because the y is given to you. So you find the derivative, find the gradient of the tangent. You can work your way through that, but then you have to turn the gradient upside down and change the sign, and then you just keep going through the steps and find the value of b. Now, just at the end, just in some of the textbooks, they don't like fractions, and so you can turn an equation of a straight line into general form by multiplying through to get rid of all the fractions, and then x has to be first and positive, and the others don't have to be. So it just depends on how the question's asked, or if you want to check an answer because it doesn't look quite right what you've got, then that's how you do it. You can ask me about that in class if you're not too sure. And I've put a worksheet on Moodle for practice, so that's the next lesson or so. Plenty of work there. Okay, see you next time.